And so for like this section, I will give you, or this chapter, you will have a unit circle given to you. You won't have to write it down or anything.
Yay, algebra bestie.
All right, so and something else you're going to notice is that the final answers to these problems will all look very similar. So if you get to the point where you're doing a problem and your answer doesn't look like what we showed today, do the problem over again because probably something's wrong. So sine and cosine are the easiest ones in my opinion, so we're going to start with those. So sine of negative 165 degrees now, I need to use an angle that is coterminal with that angle because it's negative. Okay, so how would I find a positive angle?
At 360.
At 360. So negative 165 plus 360, it's going to be 195. So I'm going to now treat this as the sine of 195 degrees. And you might be like, well, how are you allowed to do that? Well, it's in the same spot on the unit circle, so my final answer result is going to be the same. 195 is not on the unit circle. Negative 165 isn't either. So I need to find two known angles that when added or subtracted, and I don't care which one, give me 195. So this is why I say it's a lot easier to have it in front of you, because even if you know the values, trying to figure out what adds up, it's easier to see it. So 135 and 60. Yep, that's good. Let's do that. So we write this as the sine of 135 plus 60. So then we use the formula. So I'm going to go back up and look. So sine is sine times cosine, and then the same sign, cosine and sine. So this is going to be the sine of 135 cosine of 60 plus cosine of 135 sine of 60. So then from the unit circle, I need to know what those values are. So what is the sine of 135? And then cosine of 60. Plus cosine of 135.
Negative square root of 2.
And sine of 60.
Square root of 3
So then we combine. So I multiply these two together. So this is going to be square root of 2 over 4 plus. Now remember, when we multiply square roots, we can multiply what's inside. Okay. So this is going to be the square root of 6 or minus the square root of 6 over 4. And then I just combine this and write it as 1. So it's going to be square root of 2 minus square root of 6 over 4. And that's your final answer. So I say that to be sine and cosine should all look, relatively speaking, like this. Okay? Should all be some combination of square root of 2's or square root of 6 or something over 4. I would say at least 95% of the time. There's going to be some combination of those numbers. We don't typically use like 90 and something because that usually just adds to another like value that, you know what I mean? So we usually try to use other ones, and all of our values are either like 1/2 square root of 3 over 2 or square root of 2 over 2. So it kind of makes sense that it has to come out to be this way. So if your answer doesn't look like that, multiply again because probably something is wrong. Tangents are going to look different though, but still the same general visual look. they're just going to be reduced a little differently. And because tangent has square root of 3's, it's going to be 3's instead of 2's and 6's. Not that there's not any 2's, but it's less frequent.
For a second, I was gonna ask you how the denominators went from 2 to 4, and that felt really stupid afterwards.
Multiply.
Like that's not how adding them works. I see everything. I see.
All right, let's look at. And just, really quick before I do that. If you had written 60, then 135, the only thing that would happen is your answer would be like minus the square root of 6 plus the square root of 2 over 4. The book, if your answer doesn't match the book exactly, as long as your sign is with the correct number, it's fine. So, because like the book has it this way, but like when I did the problem one time before, I did 60 plus 135 instead, and so then it was everything flipped. So, all right, let's do number 6, the cosine of 15 degrees. So, how do you think we could rewrite that one?
Minus 45, or maybe 45 minus 30.
Okay, either way, it works no matter what. You could also do 315 minus 300. I mean, you can use whatever. So which one do you want to use?
So it could be 2 angles added or 2 angles subtracted.
Yes.
Okay.
Yep, so that's why we have the 2 formulas listed for each one. So we have an adding one and a subtracting one.
Oh, okay, that one.
So that we can have the freedom to do that. So which one do y'all want to use for this one? 45 minus 30. So that's typically what I will pick because it's the simplest one. I try to avoid things like 315 minus 300 because that means I'm going to end up with some negatives, and yes, they're going to cancel eventually. Well, probably, but that just seems like a lot of extra work that I don't feel like doing. So, look at the cosine formula. Cosine is the 2 cosines and then the opposite sign and then the 2 sines. So, this is going to be cosine 45, cosine 30. Opposite sign, so it's going to be plus sine 45, sine 30. So the cosine of 45 is?
Square root of 2 over 2.
Yep. Cosine of 30?
Square root of 3 over 2.
Sine of 45?
Square root of 2 over 2.
And sine 30.
1/2.
So then, and I specifically did it in two steps in the previous problem. If you wanted to go straight from here to here, that is completely fine because all you're doing is getting a common denominator. Well, let me rephrase. Assuming there is a common denominator, which there should be, then you know that this is going to be all over 4, and then you just can do the top part. So you can do, that's going to be the square root of 6 plus the square root of 2 over 4. So if you want to write the middle step of have the square root of 6 over 4 plus the square root of 2 over 4, that's fine. But if you want to just go straight to here, that's okay. So I'm going to write in this middle step here of what happened, just so if you go back, you can see it. All right, so we're going to look at a tangent one. Now, I will say that the easiest thing to do if you're given radians is to convert to degrees. Because when we have a problem like this, the tangent of 17 pi over 12 are there pi over 12s on your thing. Okay, So then it gets to be a little hairy because then you're dealing with, you either have to figure out something that has common denominators with 12 that you can reduce down and add together, which yes, you could. You're capable of doing that. Or you could convert it to degrees. That's what I would recommend. So 17 pi over 12 times 180 over pi. And just to save the calculation, that's 255. So like you'll obviously be allowed to have your calculator, but kind of like with the last stuff we did, like you won't necessarily need it, but you'll be allowed to have it in case you have to do like a conversion like this. So then I need two angles that when added together or subtracted can give you 255.
225 plus 30.
225 and 30. Yep, sure. So I'm going to treat this as the tangent of 225 plus 30.
I thought it was 255. Oh, wait, never mind. Okay, I see what we're doing now.
Yeah, we're just, sorry. Let me redo it this way. Or write it this way first. The tangent of 255 now is what we're using instead of this.
Yeah.
Now, the only time I will say don't convert is if we're doing the reverse. So if we were given, I don't even know if your book does the reverse of it or not. Yours may not. Okay, your book doesn't do it. But if you were given the reverse, so like when you get to pre-cal, they'll give you not like this final result, but it'll look like this. If that was in radians, all you have to do is get a common denominator. That you should be able to do. The reason I tell you to convert these ones is because it's just a lot easier to find two angles instead of having to sit there and find a common denominator and then figure out what adds together, because that's just a royal pain. So now the tangent formula, this is the plus 1. So same sign on top, so we add the 2 together, and then 1 minus, so the opposite sign on the bottom. So we're going to have tangent of 225 plus tangent of 30 over 1 minus tangent of 225 tangent of 30. Now, tangents are everybody's least favorite because it ends up with fractions and fractions. Or at least most of the time. But your answer ends up being pretty nice. So, what is the tangent of 225?
91.
Just one.
Okay, sorry. I was trying to find it on the thing and I just could not zone in on where the tangent was. And then tangent of 30? Then we have on the bottom 1 minus, and then we have, that's going to be 1 times square root of 3 over 3. So what you need to do, obviously this one's going to go away, so I'm just going to scratch it out so I don't have to worry about it. I need to get a common denominator on the top and a common denominator on the bottom so that I can combine this stuff on top and bottom into 1 on top and 1 on bottom. So what do I need to do to get a common denominator on top? I need a common denominator first. I can't do that yet. That's why we want to get to the point to be able to do that, but I have to get a common denominator first.
What if we multiply by 3 over 3?
Yep, so I'm going to be multiplying by 3 over 3 for both of those. So here, what I'm going to have, I'm going to write this as one fraction. I now have a common denominator. So on top, I have 3 plus the square root of 3 over 3. All over on the bottom, I have a common denominator there, so it's going to be 3 minus the square root of 3 over 3. So when we divide by a fraction, we multiply by the reciprocal, keep, change, flip. So I now have 3 plus the square root of 3 over 3 times 3 over 3 minus the square root of 3. Now, sometimes people get cancel happy and think that 3 plus the square root of 3 and 3 minus the square root of 3 cancel. They do not. Okay? The only thing that we are allowed to cancel are these 3's here. Because this stuff is being added and subtracted, you can't just cancel it away. Okay, but a lot of people think you can. So now what I have is 3 plus the square root of 3 over 3 minus the square root of 3. And maybe you're thinking, oh, we're done. But that's not allowed because we can't have a radical in the bottom. So any idea what we need to multiply by to get rid of the radical in the bottom?
Square root of 3 over square root of 3.
It's still going to give me a radical on the bottom.
3 plus the square root of 3 over 3 plus the square root of 3.
Yep. So we want to multiply by the conjugate of the denominator. So we are multiplying by 3 plus the square root of 3, top and bottom. Because what special type does that give me on the bottom? Difference of squares. So that's going to eliminate the radicals. So on the bottom, I'll do the top after, I have 3 times 3 is 9. Then it's going to be obviously the minus 3 root 3 plus 3 root 3. That stuff's going away. So then I have negative square root of 3 times positive square root of 3. So it's going to be minus 3. Now on top, I actually have to multiply. Now, it is a perfect square trinomial on top, so if you remember what that is, you can just write it. But on top, I'm going to have 3 times 3 is 9. 3 times the square root of 3 is 3 root 3, then 3 root 3. So those two added together are going to be 6 root 3, okay, which would be 2 times the two pieces added, or the piece that is the middle of your perfect square trinomial, if you remember that form. And that was a while ago. Plus the square root of 3 times square root of 3 is just 3.
So we're just foiling.
Yes, you're just foiling. I just went ahead and combined the middle because it is a perfect square trinomial. And to save me a step of writing because this problem is already very long. But yes, I will just, here, I'll note this here. This is 3 root 3 plus 3 root 3 is how I got that there. So then I combine everything that I can. So that's going to be 12 plus 6 root 3 over 9 minus 3. Or, well, I can change that to 6. We can take a 6 out of both pieces on top. So it'll be 6 times 2 plus the square root of 3 over 6. Then the 6's cancel. So your answer is 2 plus the square root of 3. So your answers for tangent will always look kind of like this.
How come the 2 on the 6 on the top became a 2 instead of a 1?
It was a 12.
Oh.
So I factored out a 6 because this is being added. I can't just cancel the 12 and the 6. I've got to take a 6 out to be allowed to do that. For the same reason of what happened up here, why I couldn't cancel these because they were being added and subtracted. So if y'all have a question about, I know we just went through that in really quick. If y'all have a question about that tomorrow, just remind me and we'll go back over it. And we should finish this section tomorrow.
Oh,